All right, AP, this is sample exercise 4.081. We're talking about neutralization reactions. So in a certain experiment, 28.0 milliliters of 0.250 molar HNO3 and 53.0 milliliters of 0.320 molar KOH are mixed. Calculate the amount of water formed in the resulting reaction. What is the concentration of H plus ions or OH minus ions in excess after the reaction goes to completion? Go ahead and press pause now because here comes the solution. And so the species available for reaction are H plus 1 and nitrate minus 1. That's coming from the hydrogen nitrate, right? We also have K plus and OH minus. That's coming from the potassium hydroxide. And so since potassium nitrate is soluble, the K plus and the NO3 minus are spectator ions. So the net ionic equation ends up being H plus 1 in the aqueous phase and OH minus in the aqueous phase. They react to yield H2O in the liquid phase. We next compute the amount of H plus and OH minus ions present. We can do that pretty darn easily by taking the volume of the HNO3, okay, that's given to us by the problem as 28.0 milliliters, and then the volume of KOH given to us by the problem, which is 53.0 milliliters. We convert both values into liters of the substance so that we can use the molarity equation to cancel out liters of each solution to yield the moles of each ion in solution. And so after doing each of these calculations, we get 7.00 times 10 to the negative 3 moles of hydrogen plus 1. And we get 1.70 times 10 to the negative 2 moles of hydroxide ions. Now, since the H plus 1 and the OH minus 1 react at a 1-to-1 ratio, the limiting reactant here is H plus 1. Why? Because there is less of the H plus 1 than the OH minus. Now notice 7 is bigger than 1.70, but this times 10 to the negative 3 compared to the times 10 to the minus 2 makes the amount of hydrogen plus 1 far less. So H plus 1 is the limiting reactant. This means that 7.00 times 10 to the negative 3 moles of H plus 1 ions will react with 7.00 times 10 to the negative 3 moles of OH minus ions, again, according to the balanced net ionic equation, to form 7.00 times 10 to the negative 3 moles of H2O. The amount of OH minus 1 ions in excess can be attained from the following difference. Your original amount given to you by the problem, then you simply subtract the amount consumed, and then you get your answer, amount in excess. And so in this particular example, we're going to take the 1.70 times 10 to the negative 2 moles of OH minus. We're going to subtract 7.00 times 10 to the negative 3 moles of OH minus. And that gives us a difference of 1.00 times 10 to the negative 2 moles of OH minus. The volume of the combined solution is the sum of the individual volumes. The original volume of HNO3 plus the original volume of KOH is going to equal the total new volume. And so that, in terms of what's given to us by the problem, is 28.0 milliliters plus 53.0 milliliters, and that is 81.0 milliliters. Now, as per our molarity calculations, we need that to be in terms of liters, and so we're going to convert this value of milliliters into liters, and that gives us 8.10 times 10 to the negative 2 liters. Thus, the molarity of the hydroxide ions in excess, remembering that the moles of OH minus over the liters of solution is going to give us that molarity, we have 1.00 times 10 to the negative 2 moles of OH minus, again, right here, divided by 8.10 times 10 to the negative 2 liters, right here. That is going to give us a molarity 0.123 molar OH minus.